In this lecture, we will see how to write the program for the decimal to hexadecimal number. Now, in this location, I have given the decimal value that is nothing but a 10. Now, tell me what is the hexadecimal value for this one? This is A. Now, we need to get this value in the next location. For that, what is the procedure? If you see here, first I am taking the initializing the accumulator with 0, 0. I'm adding the 1 value here, and here I'm getting the result 1. And again, I'm adding one more 1, I'm getting the result 2. So after every addition, what I'm doing, I'm converting into this hexa value into the decimal value by using the da instruction. And also I'm comparing the this value, decimal value with the memory location value. If it is matching means what? We have to stop the adding the 1. Otherwise, what? We need to go on adding the 1 till we get the value of this decimal value. Now for that, what I am doing, I am also counting the, I have taken one counter, and how many times I am doing the addition, that I am counting with the counter. So now if you see, for the first addition, I got the value 1. In the counter also, I got the 1. So for the second time, the value is 2, and I got the value, counter value is also 2, and so on. If I'm doing like that, for the ninth count value is 9, that time accumulator is giving 8 plus 1 is equal to 9. And next time, once again, if the comparison, after doing the comparison, if the value is not matching, then the addition will go on. This will continue till the accumulator value is matched with the location value. So comparison is not satisfied. Zero flag is not set. That's why count value will be incremented to the A, and accumulator value is what? 9 plus 1. Every time we are adding one value to the accumulator, thereby what? Accumulator, now we got the A value. Now after the da instruction, now after that what? After addition, every time we are using the da and also compare. So after the da, now the accumulator is consisting of what? Accumulator is consisting of 10. Now this is compared with the memory location. Now accumulator value and memory location value both are matched. So now here we have to stop the doing the addition of the accumulator. Now after this, what? Program is done. But now which value we need to store? Now if you see the value in the accumulator, no more hexa value is there. After the da instruction, this accumulator value is converted into the BCD value. So now here, if you see the counter value, counter is having the hexa value, equivalent hexa value. So we need to store the counter value. Now this is the analysis of the decimal to hexadecimal. Now for this, we need to write the program. So now first we need to initialize the location. So now here one more thing you have to remember, that hexadecimal values are from 0 to FFF, last location. Now how much the decimal value you apply here? Maximum decimal value 9 number, how 8 bit number, how much you can apply? 99 only. If you are converting into the hexa value, carry will not generate, so no need to bother about the carry while converting to decimal to the hexadecimal. Now what is the program for this? Now first, initialize the memory location with the HL pair, high comma HL comma. So now HL is pointing to the first location. Now after that, what I need to do, I have to initialize the accumulator with 0, 0. Why? What I said here, first I'm initializing the 0, 0. After that, I'm adding the 1. So now again, I have to initialize the counter. Now this counter value, I'm taking it as a B register. So 0, 0 H. Now here 0, 0 H. Now counter value, I moved 0, 0, initialized with the 0, 0. Now first I'll increment the counter so that it is pointing to INR B. Means what? Counter value is 1 here. Now I have to add 1 to the accumulator. That is what? ADI 0, 1H. Now the first value is added. Now after the addition, what I need to do, I have to convert into the decimal value. Now whatever the accumulator value is there, that I have to convert into the decimal value. For that, I am using the da instruction. Now after the converting into the decimal value, that decimal value I need to compare with the memory location value. Now after the first value, if first accumulator value is 1, after the addition here the accumulator value is 1. Now after the da also accumulator value is 1 only. Before 9, the decimal value, hexadecimal value, there is no change. That's why it will not give the different answer. It answers are same, and that value is compared with the location value. It is not matching, so need to compare the accumulator value with the memory location value. So CMP M. So if this is not 0, if the accumulator value and memory values both are not matching, need to add the 1 to the accumulator. So J and Z loop. Now where the loop should go? Loop should go to the increment B. Means what? It is for first value, here accumulator value is 1 and decimal value is 10, not matching. So counter value is incremented by 2 and accumulator value is added by 1, thereby accumulator value is 2, that will be converted into decimal. Again 2 will be decimal value is also 2, that is compared with the, again 2 is compared with the memory location. Now again it is not matching, and do the addition, go on, do the addition. And once if the if the value is 10 here, the accumulator, if the after the da instruction in the accumulator a value is there, and after the da again accumulator value is 10, if this 10 is compared with the decimal value, if both are matching, now we need to stop adding the 1 to the accumulator. Means what? This is supposed to come out from the loop. So now here both are matching, means what? Zero flag sets, thereby it will come out from the loop. Now we need to store the result. Now where the result is there? Now if you see the accumulator value is a decimal value. Now we need to store the result. Result value is what? A. Now if you see in this, where the A value is there, A value is nothing but a counter value. So we have to store the counter value into the this location. Now how can we do that? Now move A comma B. So B value we moved into the accumulator and store that into the 6501. Instead of this, you can also write INX H. Why? Because H is holding the 6500. If you say INX H, it will hold the 6501, and you can move this value into the memory location. B value into the memory location. Either you can use this or use this. Now, last one is what? Halt. Now this is the program for the decimal to the hexadecimal conversion.